Hello and welcome to another video. In this video we're going to be working on clone graph, and this is going to be continuing the Typescript line 75. So we're given a reference of a node in a connected undirected graph, and you want to return a deep copy clone of the graph. Each node of the graph contains a value, int, and a list node of its neighbors. So it'll have a value and a list node of its neighbors. And the node's value is the same as the node's index, one index. For example, the first node will have value 1, value 2, and so on. And it's represented in the test case using an adjacency list, but that's not really like the format of it is. That's just how it shows in the test case. So in this first example, we have a graph like this, 1, 2, 3, 4. And basically we want to create a clone graph. So we want to make all of these nodes with these exact same routes. Right? So 1 should have neighbors 2, 4, 2 should have neighbors 1, 3, 3 should have neighbors, and so on. In the second example, we have one node and there are no neighbors. So it's represented like this. We have a node and the neighbors are none. And in the third example, we have 0 nodes. So essentially what we need to do is we need to figure out, given some of these nodes, right, how do we make a deep copy? So how do we essentially make this exact thing using all new nodes? And it's kind of similar to the clone like list with next pointers. Essentially what you need to do is you need to make a hash map, and it's going to have the old node mapped to the new node, right? Those are going to be like the key value pairs. And essentially what's going to happen is, like, let's say we're just going to go through this example. So we're going to have the hash map of nothing. We're going to start at node 1, and we're going to say, okay, node 1. We're going to have first see, is node 1 in our hash map? No, it's not, right? So we're going to create a copy of it, and then we're going to map them together. So old node 1 maps to new node 1. Okay. Now we are going to say, let's just actually, for this hash map, let's take all the neighbors in the old one and let's recurse into them and add them to the neighbors. So the neighbors are 2 and 4, so we're going to say, okay, let's recurse into 2, for example. And into, is it in our hash map? No, it's not, so we're going to add 2. Okay. Now for 2, we're going to do the same thing. Let's add all of its neighbors, right? And so we're going to say, okay, well, for 2, the neighbors are 1 and 3. So let's go to 1 first, maybe. So then we come back to 1. And we say, okay, is 1 in our hash map? Yes, it is. And so if it is in our hash map, we just want to return that node, right? The node is stored in our hash map. So it's going to return over here, and we're going to create this link here. It's actually going to be, I'm actually going to show both directions. It's in undirected, but we need to store 1 in 2's neighbors, and we need to store 2 in 1's neighbors. So now we're going to come back to 2. Now we're going to go to its other neighbor 3, and we are going to say, okay, is 3 in our hash map? No, it's not, so let's add that in. Okay, and let's actually, for 3, since it's not in our hash map, we're going to do the whole neighbor thing again, right? So let's just say we go to 2 first from 3, because we need to add all of the neighbors and from original 3 to 2. So we're going to go back to 2, and we're going to say, is 2 in our hash map? Yes, it is. So that means we're going to create this link, right? We're going to return 2. Now we come back to 3, and we're going to say, okay, there's another neighbor 4. So let's go over there. And now we're going to check, is 4 in our hash map? No, it's not, so we're going to create it. Now for 4, we're going to do the same thing, right? We're going to add all the neighbors from the original 4. So they're 1 and 3. Let's go to 1 first, maybe. So we're going to come to 1, and we're going to say, okay, is 1 in our hash map? Yes, it is. So then we're just going to return the new node. So we're going to do this. Now for 4, we also need to check the other neighbor. So 3 in our hash map, yes it is. So we're going to create this connection. So now we're done with 4, right? And we'll just return 4. And now we come back to 3 because we called 4 from 3. So now 4 is going to be returned, so we can make this route here. And now we have all the routes from 3, so we're going to recurse back to 2 because that's where that was called. So this will make this route, right? We're going to recurse back to 2. We're going to get 3. And then now we're done with 2 as well, and we're going to recurse back to 1 because that's where 1 was called. And then we're going to check, okay, now that we recurse, this route is done. But also, what's the other neighbor of 1? Well, it's 4. So we're going to go into 4, and we're going to say, is 4 in our hash map? Yes, it is. Let's just get that node here. So let's write the steps. So first, we are going to create a hash map, right, that we need to store old node as the key and new node as the value. Then we need to make a function that takes a node and does a few things. So if the node is in the hash map, then we can just return the new node that's the value. Well, you also have to check if the node is null. So if the node is null, return null, because you can have a list of no nodes, as was in example 3 up here, right? So if you look over here, this would be a null node, right? So we do have to check for that. Otherwise, create the node, store old to new in hash map, and populate neighbors. And the neighbors are just going to be the same as the old neighbors. We're going to have to loop through them and call that function on all of them. And then finally, we just need to return the node. So it's populate neighbors, then return node. And we're actually going to use, and I'll show you in the code, we're actually going to use a map for this instead of an object, and I'll go through all of that. But that's pretty much what it is. So essentially, you want to make a hash map of the new node to the old node, just like you did in that copy link list. When you want to make a deep copy, you essentially want to make sure that you know where the new nodes are located, and the easiest way to do that is just to make a hash map where the key is the old node and the value is the new node. So now we have enough to code. So let's just actually full screen this and let's start coding. So first we're going to make a hash map, but because we want our values and our keys to be of type map, or not type map, type node, we actually are going to use a map instead of a node, because in a map your keys can be nodes, where in an object they have to be like strings or numbers or things like that. So we're actually going to make a map of node to node, and you have to call a constructor like this. So it's map, type node to node, and that's how you would do that. And this is pretty much like a dictionary. It's kind of similar to an object. They work in similar ways, but a map lets you use keys that are actual objects, right? Instead of just strings and numbers and things like that. And that's what we want. We want a node-to-node relationship. Okay, now we can make a function, DFS, we'll call it DFS, and it will take a current node that is either node or null, and return node or null. Oops, node or null. So now in our function, we can check if it's null. So if it's not current, we just return null, right? Like if there is no node, there is no mapping, we just return null. We don't need to map null to null or anything. Okay, now if we need to check if it's in this visited, so the way to do this with a map is visited.has, kind of like a set, current. So if it's in there, let's just return, and the way to get the value is visited.get current. So we're saying if there is a mapping there, let's just return the new node there. Now we need to actually clone the node, so we're going to say const clone node equals new node, and it's going to have the same value as the old node, right? They should be the same, exactly the same. So we're going to say let's do that, let's clone it, and finally let's mark it as visited. So visited.set current clone node, right? So the way to do it is the key is the current node and the clone node is the new node. So that's how you do a set, which is the same as in an object, obj key equals value. It's the same thing, just different format. So you use sets, you use gets, and that's how you do it there. Okay. Now we need to visit all of the neighbors. So we can say for const neighbor of current.neighbors, right? We want to get all the neighbors of the current node. And for all of those, we need to recurse into them. So we need to say clone node neighbors. And so when we first make the clone node, it's going to have no neighbors, right? So we need to make the neighbors, we need to push DFS of the neighbor. And there we go. We push it in, and finally we return clone node. Then we just have to call this DFS function and return that, right? So this will return the first node created, which is what we want. Now, funnily enough, I will mention that that I get these errors, but it still runs. So if we actually try it, which is kind of weird. I mean, maybe it'll give me an error, but when I was trying it before, it was still... Okay, so we do have an error now. So that's curious. So let's actually minimize this and let's take a look. Because when I ran it before, it ran fine. So it cannot find the name root node. So I think this is probably just a different name. I think this is just node. is the problem. There we go. Let's take a look. Okay, so it does run. Yeah, so it does run and it does submit and it's like reasonably efficient. So that's why I was really confused about why these errors are the way they are, to be honest, because when I actually ran this in VS Code, this didn't give me any errors, which was like really weird. I think I like used slightly different variable names, but it was essentially the exact same code. And it doesn't tell you on LeetCode why like you have an error, which is kind of really annoying in TypeScript. So I just said, let's ignore it. And yeah, like you can try to run this in VS Code and actually make a node and it won't give you an error. So I don't know exactly what it's complaining about. Maybe I didn't check for some kind of null thing or something that it's complaining about, but I don't really see how that could be the case. Like I can check for like if current has a value or something, but because it doesn't actually tell you what it's complaining about, it's kind of hard to find a type fix for this one. But yeah, essentially this does work, and this does work fine. And yeah, you can try it in VS Code to double check that, and I will be providing the code that you can put in there. So let's go through the time and space complexity here. So for the time, what are we doing, right? So for every node, we do have to make a copy, but we're not gonna, like this set and get is gonna be O of 1. So I think it's something like, for every node, you do have to make a copy. So let's call that like V for vertices, right, for the node. And then also for every node, you do have to make an edge. So you have to make a copy, and then you also have to like make an edge in both directions. Well, both directions doesn't really matter, right? But I think it does depend like how many edges you have total. So the more edges you have, the more you're going to recur. So making an edge is roughly O of 1, and making a node is roughly O of 1. So I think it's going to be something like V plus E. And for the space, so we are making this like map where every node will have a node that it maps to, essentially, which is O of V, which is the number of vertices or the number of nodes. But yeah, it's going to be all for this problem. I am curious if someone finds out like why this is the case. Not really sure. Like I said, I tried it in VS Code and there's no error. So they can post in the comments. But yeah, this does work. So I'm going to cut it here. And if you like the video, please like it. And please subscribe to the channel. And I'll see you in the next one. Thanks for watching.